Before we talk about recovering corrupted blocks, let's ask a simple question. What if only one or two blocks in a huge data file are damaged? Do we really need to restore the entire data file? Not necessarily. Oracle RMAN provides block media recovery, which allows us to target specific corrupted blocks instead of restoring everything. In this video, we will look at what block media recovery is, how Oracle detects corruption, how RMAN recover individual blocks, and when this approach makes sense. Block media recovery is an RMAN recovery feature designed specifically for individual corrupted blocks. Instead of restoring an entire data file, RMAN focuses on only the affected blocks. It finds a good copy of the blocks from the backup, restores it, and applies the necessary redo to recover it. The major advantage is the recovery scope. We are fixing the problem without necessarily replacing LD parts of the data file. Let's say we have a 500 gig data file, but only 2 blocks are corrupted. Restoring the entire 500 gig just to fix those 2 blocks would mean moving a huge amount of data unnecessarily. With block media recovery, RMAN can target these specific blocks. That means less data movement, a smaller recovery scope, and potential much less recovery time. So the idea behind block media recovery is simple. Fix only what is broken. Before performing recovery, we need to understand the type of corruption. At a high level, Oracle corruption can be physical or logical. Physical corruption means the block itself cannot be read correctly. Logical corruption means the block can be read, but its contents are inconsistent or invalid. Understanding the type of corruption helps us determine what happened and how we should respond. Physical corruption is associated with damage to the actual database block. For example, problems with storage, disks, or I/O can cause a block to become unreadable. Oracle may report an error such as error 01578 when it encounters a corrupted block. As DBAs, we need to investigate both the database error and the underlying storage environment. The important point is that a physical corruption can affect a specific block without unnecessarily meaning the entire data file is damaged. Logical corruption is slightly different. The block may be physically readable, but information inside it is not logically correct. This can be associated with software problems or memory issues, and it may be discovered when Oracle assesses the block or when validation is performed. So when investigating corruption, we shouldn't just ask, is the block readable? We also need to determine whether the information inside that block is valid. So how do we actually discover these corrupted blocks? Corruption can be detected when the database accesses a problematic block. RMAN can also identify corruption during backups or validation operation. DB Verify is another tool that can help with checking database file. And Oracle provides the database block corruption view, which gives DBAs information about blocks Oracle has identified as corrupted. This gives us a starting point for identifying the affected blocks. Once corruption is identified, we need to know exactly where it is. The important information includes the file number, block number, and corruption type. The file number tells us which data file is affected. The block number tells us exactly which block needs attention. This level of details is important because block media recovery is targeted recovery. Instead of saying this data file is corrupted, we are able to say this specific block is corrupted. Once we have identified the corrupted block, the recovery process is straightforward. First, we identify the corrupted block. Next, RMAN locates a good backup copy. That block is restored and the required redo is applied. Finally, we validate that the recovery was successful. Notice the difference from a traditional data file restore. We are recovering the specific damaged block while leaving the rest of the data file untouched. If you know the data file and block number, we can target it directly. For example, recover data file 5. Block 12345. Here we are telling RMAN to recover block 12345 in data file 5. That is extremely precise. We are not restoring data file 5 completely. We are targeting one specific block. This is exactly what makes block media recovery useful for isolated corruption. But what if several blocks are corrupted? We don't necessarily need to specify every block manually. RMAN provides recovery corruption lists. This tells RMAN to use the database known corruption lists and recover the affected block. So instead of handling multiple blocks individually, RMAN can process the known corruption list for us. Let's specify what happens during block media recovery. First, RMAN finds a good copy of the corrupted block. Second, it restores that block. Third, the entire redo is applied. Then the block is recovered and its consistency is validated. The important thing to remember is that this is targeted recovery. RMAN is repairing the affected block rather than replacing the entire data file. Block media recovery is most useful when only a few blocks are corrupted and the rest of the data file is healthy. It is particularly useful in a production environment where downtime needs to be minimized. But there is one important requirement. We need good backups from where the affected block can be recovered. So block media recovery is a targeted solution for isolated corruption. It's not necessarily a replacement for every other recovery method. Block media recovery isn't the right solution for every corruption problem. If corruption affects a large portion of a data file, recovering individual blocks may no longer be practical. It's also not useful if the required backups aren't available. Several structural damage, major system or undo problems, or an unavailable data file may require a broader restore and recovery operation. So before running a recovery command, the DBA needs to understand the scope of the damage. The best way to deal with corruption is to detect it early. Regularly run RMAN validation and monitor the corruption information available in Oracle. Maintain correct and reliable backup because block media recovery depends on having a good backup copy. Storage health should also be monitored, especially when the physical corruption may be related to I/O or storage problem. And finally, test your recovery procedure. Knowing that a backup exit isn't enough, we need to know that we can actually use it. So let's wrap this up. Block media recovery targets individual corrupted blocks instead of restoring an entire data file. RMAN uses a good backup copy and applies the redo to recover those blocks. This can reduce recovery time and minimize the disruption. But remember, block media recovery works best when corruption is isolated and good backups are available. As a DBA, don't just memorize the recovery command, understand when to use it, when not to use it, and how to detect corruption early. If this video helped you, like the video, subscribe and drop your question in the comments.